Chapter 5 Introduction to Euclid's Geometry. First exercise. Which of the following statements are true which are false? Give reasons for your answers. First statement. Only one line can pass through a single point. That statement is false. We know that through one point we can draw infinite number of lines. So the reason is we can draw infinite number of straight lines passing through a point. Therefore that statement is false. Second one, there are an infinite number of lines which pass through two distinct points. Through a single point infinite lines we can draw, but through 2 points only one line can draw. So that statement also false. Through two distinct points only one line can draw. Third statement, a terminated line can be produced indefinitely on both the sides. That is true by using the postulate 2 says that a terminated line can be produced indefinitely. This line is the terminated line AB. If you are thinking that way, then we can extend that line endlessly on both the sides. So that statement is true using the postulate 2. Now fourth statement, if two circles are equal, then their radii are equal. Two circles are equal, then their radii also equal. Radius that will be equal. That is true. So reason is superimposing. That means one circle if you are keeping on top of the other. The region of one circle on the other, we find the both of them are coinciding. That means their centers and boundaries are coincide. And their radii also will be equal and coincide. Wherever we are taking, that will be equal and coincide. So we can say that statement, if two circles are equal, then their radii are also equal. Fifth one, in this figure, AB is equal to PQ, PQ is equal to XY, then AB is equal to XY. That also true. According to Euclid's axiom, things which are equal to the same thing are equal to one another. If AB is equal to PQ, we can write AB is equal to PQ and this PQ is equal to XY, which implies first one is equal to XY. So that statement is true by Euclid's axiom. Second question, give a definition for each of the following terms. Are there other terms that need to be defined first? What are they and how might you define them? Here some other terms are coming here. So we can write yes. We need to have an idea about the terms lines, point, circle, quadrilateral, ray, etc. And after that we had to define all these terms. First one, parallel lines. We know that two lines extending endlessly to both sides and the distance between the lines is same everywhere. Then we can say these lines are parallel. Definition, two lines L and M are in a plane said to be parallel if they have no common point. When we are extending, it is not intersecting, not meeting each other. No common point. So we can say here L parallel to M. Second one, perpendicular lines. Two lines lying on the same plane are said to be perpendicular if they form a right angle, 90-degree angle. One is horizontal and the other one is vertical. The angle between the lines, that is 90-degree right angle. Then we can say that is perpendicular lines. Next point, line segment. Line segment we have, that means two endpoints and it has fixed or definite length. We can measure the length of the line segment. So we can write the definition. A line segment is a part of line and having a definite length. It has two endpoints. Here we can write that as AB, endpoints A and B and the line segment on top. line segment AB or BA. Next is radius of a circle. Here the circle, and we know that the distance from the center to the circle is called radius. The distance from the center to a point on the circle is called radius of the circle. Here line segment PQ. PQ is the radius. Next term is square. Square, a quadrilateral with all four angles 90 degree and all four sides are equal in measure. Then we can say that is square. Here ABCD is a square. Third question, consider two postulates given below. First one, given any two distinct points A and B, there exists a third point C, which is in between A and B. Second postulate, there exists at least 3 points that are not on the same line. Then the question, do these postulates contain any undefined terms? So we can write, yes, these postulates contain undefined terms such as here point and line is coming. Also there is no information about the points are on the same plane or not. Points are in the same plane or not. The position of point C is not given here, as whether it lies on the line segment AB or not. So some clarification we need it here. Then, are these postulates consistent? We can write, yes, these postulates are consistent when we deal with the two different situations. These are two different situations. First is saying the third point C, which is in between A and B. Second one is saying at least these 3 points are not on the same line. So we can write in first case, point C lying on the line segment AB in between A and B. Second case, point C does not lie on the same line segment AB. So these are two different cases. Then, do they follow from Euclid's postulates? Explain. No, they don't follow from Euclid's postulates. They follow the axioms. Fourth question, if a point C lies between 2 points A and B, C lies between 2 points A and B such that AC is equal to BC. That means from A to C, that is same as from B to C. Then prove that AC is equal to half of AB. Explain by drawing the figure. So AC is equal to half of AB. So here it's given AC is equal to BC. That is given. Then we are adding AC on both the side. AC plus AC is equal to here also BC plus AC. Using the postulate here, if equals added to equals, then the wholes are equal. If the same quantity adding on both sides, that value will or both the sides are again remain as equals. So AC plus AC, here we are getting 2AC. This side BC plus AC. BC plus AC, that means AB. So 2AC is equal to AB. Then AC is equal to half of AB. So we proved AC is equal to half of AB. Hence proved. Fifth question, in question 4, point C is called a midpoint on the line segment AB. Point C is the midpoint of line segment AB. Prove that every line segment has one and only one midpoint. To prove that, first we are taking here two midpoints. Let C and D be two midpoints of AB. Just assume like that way two midpoints, and after that we can see that is coming the same point or coinciding. Now here AC is equal to half of AB. Already we proved in the previous question AC is equal to half of AB. And AD is equal to half of AB. If D also another midpoint, then we can write AD is equal to half of AB because the midpoint half of the full line segment. Then subtract. This we can mark as equation 1 and this as 2. So 1 minus 2. 1 minus 2 gives AC minus AD is equal to half AB minus half AB. Right side that will become 0. Which means AC minus AD is equal to 0. That means AC is equal to AD. If AC is equal to AD, which means C is equal to D. Which implies C is equal to D. C and D are coinciding. That means every line segment has one and only one midpoint. Only one midpoint. Question number 6. In this figure, AC is equal to BD. Then prove that AB is equal to CD. So here it's given that AC is equal to BD. From A to C is equal to B to D. Then AC we can write as AB plus BC. That is AB plus BC. Which is equal to BD we can write as BC plus CD. Now we can see BC is here on both the side. So if we are minusing BC from both the side, we will get AB is equal to CD. We can write that already here that we had to prove. So the reason is that when equals are subtracted from equals, remainders are equal using the rule. So we can write here subtracting BC from both the sides which implies AB is equal to CD, and the reason is when equals are subtracted from equals, remainders are equal. So AB is equal to CD, hence proved. Question number 7. Why is axiom 5 in the list of Euclid's axioms considered a universal truth? Note that the question is not about the fifth postulate. So Euclid's axiom that we are considered as the universal truth because as the statement that is true in all the situations and in any part of the world. Everywhere that statement is true. Therefore we can say it is considered as universal truth.